honor to introduce our keynote speaker, Ms. Rebeca Jimenez. Ms. Jimenez joined Amkor in 2014 and is currently the Corporate Vice President of the Advanced Silicon Photonics Business Unit. Prior to assuming her role, Ms. Jimenez served in various sales and strategic program management roles. She has more than 25 years of experience in the global semiconductor industry. Prior to joining Amkor, she spent 15 years with IDT, previously ICS, in test engineering and operational roles, as well as management positions. In addition, Ms. Jimenez worked in various engineering and engineering management roles at Motorola. She holds a BS in electrical engineering from Arizona State University, as well as an MS degree in electrical engineering from the National Technological University. Please join me in giving Ms. Jimenez a very warm welcome this morning. Here you go.
Great. Thank you, Karen.
You're welcome.
Thank you, and good morning to everyone here. I hope you had a productive day yesterday. Also, thank you, Karen and Amy, for the inspirational words this morning. Please sign me up however I can support this initiative. That would be an honor. So today, Amy mentioned it a little bit. I'll be talking about advanced packaging and test. So about 20 years ago, I faced a test challenge. I think we're all facing test challenges every day. I was working for a brand new business unit in an existing company, so because we were working on the latest products, we were given the budget that we needed, and we bought the latest and greatest mixed signal tester at the time. This tester was $1 million, so we went through developing the products, doing the characterization, release. We're ready to release it to production. So I went to my boss and said, okay, we need the other $1 million to be able to put it in our offshore facility. And he said, another $1 million? I'm not giving you another $1 million. So I said, well, now how are we supposed to test this in production? And he said, well, figure it out. So we had to build a PC-based tester. Because need is the mother of all inventions, and challenges feed innovation. Technology is changing at a very rapid pace, which is forcing us to rethink how we innovate to assemble and test tomorrow's technology. I was asked to give this keynote here today on mine and Amkor's view of the future. Digital economy and digital transformation. What does this all mean? What does it mean in the products that we use every day, and also in how we use them? Semiconductor technology is the heartbeat that makes digital transformation happen. Silicon, packaging, and test turn innovative ideas into reality. Okay. So today I will cover 4 topics. I will start talking about the macro trends and the catalyst for semiconductor growth. Then talk a little bit about advanced packaging and test and how this is enabling the growth. Then move on into some of the evolving test requirements, and then just close with a summary of the future of advanced packaging and test. Okay? So the macro drivers that are causing the world to move from globalization to localization or deglobalism are important to understand relative to all supply chains, and for us, on the semi-supply chain. If we think we're all going back to the old normal, we have a big surprise. We're not going back to that old normal that we were all familiar with. The supply chain disruptions are not temporary. They're not going to normalize anytime soon. We have to get used to a new normal. One of the items is the world must de-risk its dependence on China. We have a responsibility to assess our supply chain risks and take action to mitigate future disruptions. The semi-supply chain will transition from mostly Asia to 3 primary regions: Asia, US, and Europe. Recognizing this trend and being able to act on new opportunities is essential. This is essential for the success of the semiconductor industry overall. So in the past, there were individual growth drivers that peaked and then declined. Currently, we have multiple catalysts that are all driving growth simultaneously. First, let me start with communications. This is driven by mobile and accelerated by 5G. This is a key driver for digital economy, and it leverages the new spectrum from 3 gigahertz up to 9 to 38 gigahertz, pushing higher data rates up to 100 times 4G speeds. With low latency and enhanced spectral efficiency, which significantly expands network capacity. In 2022, it is expected that over 50% of the phones will have 5G capability. This drives semiconductor growth by continued adoption of the wireless standards. Next, we're going to talk about computing, and here it's all about data. It's about data generation, data transfer, and data storage. Data generation for processing is estimated to grow from 1,000 exabytes per month to 13,000 exabytes per month. How much is 1 exabyte? It's about 200 million DVDs, probably more than any of us will be able to watch in our lifetimes. Global mobile data traffic is expected to grow rapidly with a 25% CAGR over the next 5 years. For automotive, it's not about the number of cars, but it's about the semi-content in the cars. New applications like ADAS, infotainment, and electrification are all driving increased semiconductor growth. And last but not least is IoT. Here, it's all about connectivity, whether it's homes, industrial, or wearable applications. Wearables continue to gain a lot of adoption with year-over-year growth over 30%. Health and fitness are some of the applications that are fueling this growth. And then across all of this, we have 5G, which enables connectivity in all these segments, whether it's cloud computing, communications, automotive, and vehicle-to-anything communication, and IoT. So now let me take a little poll. Who here faces the largest test challenge in the communications market? Okay, not much in communications. What about computing? Computing? Okay, thank you. What about automotive? Who's facing the largest test challenge with automotive? Okay. And what about IoT? Who's facing the largest test challenges in IoT? Okay, so I think not a lot of you raised your hands, but I would say that it's pretty much about even. I mean, these are all of the challenges that we're all facing today. So with this, I'm going to move on. I'm going to focus on these 4 key drivers and talk about how these are affecting advanced packaging and test. So first megatrend is 5G. Rising 5G communications increases the RF consumption to manage complex, multi-mode, multi-bands, plus the introduction of millimeter wave spectrum. Growth here starts with 5G, not only in the smartphones, but the smartphone is just a building block for our digital society and our digital economy. The pandemic changed the way that we do business to remote, whether it's remote business, remote learning, remote shopping, all that is changing. The launching application is the smartphone, which is 5G has been proliferating since 2019. In 2020, over 300 million of the smartphones had 5G capability. In 2021, it was about 750 million. And by 2022, it's over 900 million of the 5G phones, which is over 55%. Next, to talk a little bit about the package drivers here. The semiconductor content of a 5G phone is significantly higher than that of a 4G phone. And this is due to the RF requirements. 5G connectivity requires more bands. A 4G phone has 15 bands, and a 5G phone has 30 bands. This requires significant 4x increase in the number of RF components in a phone. Now that there are so many more components, but the same amount of space, you need to package them in a much smaller form factor. This is where more integration and chipset miniaturization becomes critical, and this requires advanced packaging. Besides connectivity features, further sensor proliferation in the phone is occurring. from identification of tests of sensors like time of flight or fingerprint sensors, or optical sensors, which are all being integrated in the phone. So what does this mean from a test perspective? Well, now we have to test millimeter wave, RF. We have to test over the air, something that we haven't had to do in production in the past. Antenna in package, chamber testing. For MEMS, now we have multiple MEMS components in one package. So it becomes a challenge to test different sensing functions at the same time. We also have more optical content. And then finally, we have more complex systems with subsystem modules, which means that we have increased SLT complexity. So here's an example. Who remembers the first iPhone? I remember staring at my brothers in awe. Just how can I connect to anything on the internet with this phone, even if I don't have Wi-Fi? I mean, it was such a revolutionary concept that I remember that moment so clearly. Well, that first generation phone had a front and backside board, and it had less than 50 components. Today, the iPhone 13 has a front and backside board, and a front and backside of the top board, and then it has a bottom board with one side as well. This is over 120 components, all in essentially the same form factor. When I showed this picture to my son, he says, wow, it looks like going from a town to a metropolitan city. So all this requires innovation that all of us have to bring to packaging and test. So the next trend is automotive. And as I mentioned, this is driven by content and features. The automotive semiconductor market is a long-term growth driver, not driven by volume, but driven by the content and the increasing semiconductor content per vehicle. We also see many fabless companies that are now getting into automotive, companies that were not traditionally automotive, and this is giving us a tailwind. More advanced features like advanced driver assist, electrification, and in-car networking and entertainment are all driven by advanced packaging and advanced nodes. How many of you drove here in an internal combustion engine vehicle? Okay, well, your cars have on the average, about $500 of content per car for semiconductor content. How many of you drove here in an electric vehicle, any type, hybrid, electric? And a lot. Okay, well, semiconductor content in those cars is anywhere from $650 to $950 and greater, and continues to increase. From a packaging perspective, these trends require the shift to advanced packaging, from more traditional wire bond packaging to more advanced packaging. MEMS and sensors are designed in higher nodes and 200 millimeter wafers. These are packaged either over-molded for inertial sensors like gyro and accelerometers, exposed die for temperature and humidity, and cavity for pressure sensors. MCUs are primarily in LQFP and CABGA, moving increasingly to flip-chip BGA and even flip-chip CSP. Flip-chip CSP is a package that traditionally had not been used for automotive in the past. Here we see a lot of shift to advanced nodes and 300 millimeters as well. ADAS computing and infotainment solution also are using advanced nodes, shifting to 300 millimeter wafers, and depend on flip chip packages and SiP, system in package. Finally, image sensors, which were around 90 nanometers, are now being considered at 28 nanometers, and also support the shift to 300 millimeters. These are in optical sensor packages with clear glass top, in a molded or a ceramic cavity. So from a test perspective, I think with all the wafer size changes that I mentioned, all of you are facing many probe challenges today. Other challenges in automotive are the 0 DPPM requirements, which drive for board level testing and burn-in. We have system module, again, SLT complexity, and for automotive, sometimes this means temp testing. And then we have the emergence of dynamics and system test as well. So according to the Society of Automotive Engineers, there's 5 levels to autonomous driving. Let me start with level 1, feet off. I think we all feel pretty comfortable. I think we've all been using cruise control probably for at least, probably as long as we've been driving. So we're very comfortable with feet off. Hands off. Now we start moving, right? I got my first car that actually had automatic steering last year. And I have to say, it's a little bit freaky. I mean, I kind of take my hands off, but I'm still kind of keep them closed. I'm getting used to it, but I'm not quite there yet. Eyes off. How many of you would feel comfortable closing your eyes when you get in your car? Probably not many of us. What about mind off? How many of us would feel comfortable getting in a car and doing something completely different altogether? I think we're still a bit away, feeling comfortable with calling an Uber and having a driverless car show up. But when it comes from a technology perspective, we already have all of the building blocks to make this happen. To go from a level 0 takes about 7 sensors, and to go to a level 5 takes 37 sensors. So it's more sensors and the introduction of new sensors like LiDAR, but these are all camera, radar, LiDAR, and ultrasonic sensors, which we have today. So the next megatrend is data. With 5G and digital transformation of the communications, automotive, industrial, and consumer segments, data centers and cloud computing are experiencing significantly steady growth, from the hyperscales like the Amazon, Google, Facebook, to edge computing like IBM and HP. The data intensity going over the network and being processed into the data centers is growing by a factor of 10. This increased data stream requires more processing power in the data centers. It requires AI processors, higher speeds in the network, and that drives more semiconductors. Memory storage and memory interface chips are expecting meaningful growth, whether it's to update existing data centers, upgrade, or whether it's for building new data centers. So now to talk about the packaging here, high-end servers and data centers are consuming the leading edge silicon, whether it's 3, 5, 7 nanometers. And these use larger nodes, larger flip chip BGA packages, and also 2.5D integration. All this advanced technology is needed for high-performance computing processors and graphics modules. Heterogeneous integration is becoming prevalent in this segment. And then next, we have this ultra-fast 800 gigabit Ethernet switching in the horizon. This is driving co-packaged optics and is using silicon photonics. So from a test perspective, now we have increasing bandwidth and increasing I/O, which means smaller probe pitch. We have a chiplets architecture where known good die and SLT becomes more complex. And for the silicon photonics, we have optical probe, fiber attach, and light source test. So here we have an example of a Google data center. A rack is made up of processors, switches, PHYs, servers, NIC controllers, SSD controllers, memory, oscillators, capacitors, resistors, and inductors. In each hyperscale data center, there's over 10,000 switches, and there's over 100,000 servers. How many ICs would you say are in one of these data centers? Who would say it's over 1 million? Okay. Who would say it's over 5 million? Who would say it's over 10 million ICs? Okay, so basically the number of ICs in one server is 120. The number of ICs in each rack is anywhere between 1,500 and 2,000. So those of you that answered over 10 million, you are right. There's approximately 12 million ICs in one of these data centers. So the final megatrend is IoT. Here, wearables is a leading application. Smart watches, fitness trackers, biometrics, hearables, audio, all this is driving the IoT and the wearables. And we also see more and more health applications coming on board. Here, another thing, here the value proposition is integrating multiple functions into one small form factor. And security is also key, right? We don't want somebody taking over our microphones, for example. Here are some of the enabling technologies, our system and package, which gives us full system integration. Here you're integrating an entire system, maybe a smartwatch, into one system. Miniaturization and customization is key. Always on sensing, like when you have, again, your smartwatch heart rate, it's always on sensing. And health and time of flight proximity sensors. From a test, now you have even more complex systems that you have to test, driving this increased SLT complexity. You have secure test environments, like I was mentioning, and then optical-based health vitus monitoring. So we need these technologies to be able to test some of this health monitoring. So here we have an example of just a couple of consumer products that I'm sure we're all very familiar with. The smartwatch has anywhere between 24 and 46 components. And these are these very small, system boards on what we call one chip because it's overmolded. Hearables, now you have 32 to 56 components in something that basically fits in your ear. Not only that, that's not a traditional, rectangular form factor that a lot of us are familiar with. So all this continues to drive need for innovation in technology, packaging, and test. So let me talk a little bit about these evolving test requirements and capabilities. So first, let me start by giving you an overview of Amkor's test services. So Amkor, we probably test a lot of the products that your companies manufacture, or a lot of the semiconductors that are in products that you use every day. We have 24/7 operations. We provide the full turnkey, from inception to production, whether it's wafer probe, final test, assembly, SLT, we provide all of the services. Something that we're probably very known for, and something that we've been trying to grow, and I'll talk a little bit more as to the reason, is test development. So we also offer test development engineering services. We test for all markets, which is great because it gives us this visibility into all of the emerging markets, all of the trends, mega trends that I discussed. We're also the largest automotive OSAT. There's tests in over 3,600 locations. We have over 3,600 testers in 7 locations. And even though we test billions of units and probe millions of wafers annually, we take pride in every single unit that we test and ship. So in the locations, here's the 7 locations. These are all located in close proximity to where we provide assembly and test, to where we provide assembly. The reason for that is, of course, the cycle time. When you assemble and test in close proximity, you gain cycle time, but also for yield, right? The faster that you can have that feedback on the yield, you can save product, you can save time, and provide better quality. So the factories, they're arranged more by assembly technology. So we have 3 factories where we manufacture what we would call mainstream products mostly. And this is in Japan, in Philippines, and in Malaysia. And then we have the factories that do the more advanced products. And these are Korea, Shanghai, Taiwan, and Portugal. We announced some exciting news that we're building a new factory in Vietnam. This is going to be a massive factory. Initially, the target is for system and package. We were looking for another site to diversify these products that are all built in Korea today. But what has been really exciting is the response that we've had from customers. As I mentioned, with the geopolitical issues that we're seeing, this is providing a factory in a location that's very attractive. So again, just some exciting growth and us having to adapt to the changing environment. OSATs have traditionally been an afterthought. I think I worked at semi companies before, and you kind of work through the design and even design the package, write the program, the test program, define which tester you're going to use. And then at that point, you're like, oh, I need to find an OSAT. So by the time we get that RFQ, the package has been designed, the test program has been written, the test platform has been chosen. So our value here is really in buying the tester per our customer requirements, and then just providing our expertise. You know, we have a larger tester base, we provide capacity based on forecast, and we give, throughput and yield improvement. Sometimes the customers have their own testers. They want to consign them on our floor. That's another model. And here our value is by providing best-in-class operations, production support, and test optimization. So that's the second model. The third model is more of a mix of both, which is common as well. However, with the slowdown of Moore's law, packaging and test are becoming a more critical part of the design process and not merely an afterthought. So with this, a new model evolves. A new model where we have to work closer and earlier in the design cycle so that we can be part of that solution and not just an afterthought. This is what I like to refer to as a customer virtual floor. We essentially become an extension of the customer's operations. And here we can provide flexible business models, engineering, development, engineering support. So again, trying to show how we have to evolve not only in our technology, but also in our business models. It is no surprise we're facing unprecedented supply chain challenges. I am sure that more than one of you has had a family member or friend come to you who in the past only referred to chips as in potato chips. Ask you, what's going on with chips? Why can't I get my car? Why can't the car manufacturers get the parts that they need so I can either fix my car or buy a new car? Well, this is, we've all been facing this. And as we go through this, something that has become glaringly obvious to me is that partnerships are critical. Partnerships have always been important, but I think today they're critical more than ever. This is, as OSATs, we need to evolve on how we work with our customers and our suppliers. On customer partnerships, like I was mentioning, we need to be focused on solving customers' problems, whatever those may be, whether operational, technological, supply chain. We need to work closer together on joint roadmaps and optimizing the value proposition. With our vendors, it means we need to partner in developing capability so that we can approach our mutual customers. We need to together not only provide product solutions, but also provide supply chain solutions. So let me give one example of a joint customer partnership. I mentioned I was going to talk a little bit more about test development. I think many of you work for semi companies and are very familiar with this flow, right? There's a new product, then there's some design and simulation, the hardware, software needs to be built, then you choose your ATE site, and then once it starts ramping to production, it's typically where the OSAT would get involved. We offer all of these services now as an effort to, again, evolve our models where we are working with some of the leading customers in developing the programs for them. Again, I think it brings closer collaboration and the value of developing where you're testing production. It's also helping, we're all facing labor challenges today. I think it's becoming very difficult to hire talented resources. So we're able to provide these services at the location where the production will be tested. We previously highlighted 5G as a key market moving forward. So I want to highlight one of these supplier partnerships where we're actually working with a supplier on enabling a 5G test solution. So how do we go about these supplier partnerships? First, we work with the leading test vendors. Then we jointly develop a fully integrated solution, right? So now we're wanting to look, again, I talk about supply chain. I talk about things being more integrated rather than individual. We can do everything, we've worked on test door handler, board, connectors, and pins. And then the final thing is an additional aspect to the strategy is we want to win the hearts and the minds of the test engineering developers and customers, and also our own test development engineers, to have the most friendly, productive development environment. So again, just trying to highlight how we have to evolve on the way that we do things. There are a number of key areas we consider when we work towards transforming our vendor relationships from transactional to true partnerships. Many of you are test engineers and Amkor's customers. Some of your companies have your own tester fleets, your own manufacturing sites. So the question is, how can we add value? How can we help as packaging and test technologies advance? In summary, it comes to providing end-to-end solutions with services from engineering to HVM, from probe to SLT, and with the expertise of working with all of the industry-leading customers. So I remember, early in my career, I went to my boss and I said that I wanted to understand the full semi cycle. So somehow I convinced him to let me do the whole thing, from inception to production. I'm not sure how I convinced him. I'm not sure what I was thinking at the time. But once I got into it, I had to make it work. So, I had to, after the design, which had its own challenges, made me realize I did not want to be a circuit designer. Then I had to, write the probe program, pick the probe platform, design the probe card, write the final test program, pick the final tester, release it to production, design the load board. Thankfully, there was no SLT at the time. But this basically is a flow that many of you are very familiar with. And it describes the test flow that we have been using for a long time, 20 years, 30 years. So now, how does that change? Now, we have these multi-chip system and packages, heterogeneous integration, 2.5D. What does this all mean from a test flow perspective? Well, it makes it a lot more complex. We start with probing not one die, but multiple die. Sometimes probing, wafer level fan out. Sometimes we'd have to do wafer level burn-in. Then after that, we go into this heterogeneous integration packaging, which has some test steps in between. Then we move into SLT, and there's all kinds of SLT complexities, like I mentioned, whether it's different temperatures, whether it's a board, a system. Then we get results. Well, these systems are very expensive. We can't just throw away the bad parts. So now we have to have an entire process of how do we deal with the rejects? Do we do additional stress? Do we do FA? How do we do lot acceptance and eventually post-test? So basically, it is critical that we work together as an industry for the most efficient and cost-effective methodologies for advanced, as advanced packaging and test evolves. So I will end with a couple of examples of evolving test technologies. With 5G millimeter wave, we have the challenge to test over the air. On the left, we have a conductive test environment, which is more traditional to what we're used to, but we need to transition to the right, which is a radiative test environment. Here we have an anechoic chamber as part of the platform. The end application demands over-the-air transmission and reception. Customers are demanding that production test in a mode similar to the application. Therefore, higher frequency, higher are the signal losses and the transmission medium, air, microstrip, cables, carrier frequencies, all these dictate the production test site. This is a major shift in how we have traditionally tested ICs in the past. Finally, with UPH increases, we have, from left to right, we have to support massively parallel test platforms. On the left, we have where we started with traditional ATEs testing a system on a chip. Then we move to something like a Hontech handler, where we might not be testing an entire system, but we're testing a board. We're testing an application board, so part of a system. And then most recently, something like the Titan, where we're testing entire systems, and all these with high level of There are macro drivers and semi-growth catalysts that are making us rethink our corporate strategies. Rethink not only the way that we look at technology, but the way that we look at supply chain and the way that we look at business models. Moore's law slowing down means packaging and test are accelerating. So now we have to innovate even more than ever to continue to advance the technology forward. Business models have to evolve. We can't do business in the way that we've always done it. From my perspective, it means getting engaged earlier in the customer design cycle. It may mean something different for each of you. And then partnerships are critical. Partnerships are what is needed to turn innovative ideas into reality. And with this, advanced packaging and test are no longer the afterthought. They are what are enabling the growth. So thank you with that. I invite you to, I think we're going to open it up for questions. I also invite you to either, if you want to have further discussions in the breaks, social media, I'll be around. So thank you.